This video, what we're going to do is we're going to talk about trigonometric functions, but we're going to talk about coterminal angles. So what is that all about? Coterminal angles share the same terminal side from standard position. So what does that mean? All right, what does that mean? That means that basically a coterminal angle, you got an angle, okay, this is my angle, okay, and we'll call this theta. Coterminal means that they share the same side from standard position. So a coterminal angle could be something going over this way. You see that this angle goes the other way. That's coterminal. So when it talks about finding a positive or negative coterminal with any given angle, 30 degrees, all right, here's the easiest way I could tell you. Plus or minus 360. If I add 360 to this, I get 390 degrees. Does that make sense? If I subtract 360 from this, I get negative 330 degrees. Those are my coterminal angles. Same thing for negative 6 pi over 5. I'm going to just do negative 6 pi over 5. I'm going to add 2 pi. Now, adding 2 pi is like adding 10 pi over 10. Or sorry, 10 pi over 5. So then that gives me 4 pi over 5. The same thing if I subtract it. So if I go 6 pi over 5 minus 10 pi over 5, the negative one is negative 16 pi over 5, if that makes sense. Why don't you try to do C, 3 pi over 7, give me a positive and a negative coterminal angle. All right, so with this, it says the trig ratio is on the coordinate plane. If you could think about this here we have is a angle, and realistically, if I say that this is a standard position angle, how far it moves in the x direction, left or right, we can call that x. How far it goes up and down in the y direction, we'll call that y. Because I mean, you could just move it around. And so then this is some sort of radius if we're thinking of our unit circle. So what I want to show you is this. Let me add one of these here. So basically, here's my angle right there. We'll call this R. Well, if I take this point right here and I come down this way, this is y and this is x. Is everyone okay with that? Now, realistically, if I call this theta, I know that the sine of theta is equal to Oscar had. So how about y over r? I know that the cosine of theta is equal to Oscar had a heap of apples. So that's x over r. I know that tangent of theta is going to be equal to of apples. So y over x. Now, if I wanted to find the length r, isn't r equal to the square root of x squared plus y squared? That's Pythagorean's theorem, isn't it? I think it is. So go back and let's check this out. If we go back to this, here we have two different points along this angle. We have 3, 4 and 6, 8. Do you see that? We have 3, 4 and 6, 8. Let's go back and let's see what we have here. If we go back to, so we had 3, 4 and we had 6, 8. Well, if I wanted to do this, I wanted to find r of the first point. Isn't that the square root of 9 plus 16? So isn't r1 just 5? And then if I wanted to do this guy, we'll call it r2. Isn't that the square root of 36 plus 64? And so isn't r2 just 10? All right. But what if I want to find the sine of theta for the first one? Well, if I want to find that, well, y is 4, so that's 4 over 5. If I want the cosine of the first angle, that's 3 over 5. And if I want the tangent of the first angle, well, then that's just 4 over 3. Same thing, is that true for this guy? If I go over here and I go to the sine of the second angle, well, that's going to be 8 over 10, which is 4 over 5. The cosine of theta is going to be 6 over 10, or 3 over 5. And the tangent of theta is going to be 8 over 6, or 4/3. Weird that that has just happened. I wonder why something like that has happened. Huh. This is probably important. Regardless of the length of the radius, the trigonometric ratios remain the same. That's true for everything. That is true for absolutely everything. So if we take that information and we bump it up over to the unit circle, realistically, anywhere along the unit circle, because this could be here or this could be here, we can call this a relative x comma y. It does not matter where we put our angle. If we think of the unit circle, then according to that, then we can say that the sine, like in this case, if we say the sine of angle t is equal to, I believe it's equal to y over r, but the radius is 1, so y is equal to the sine of t. Well, if that's true, then x is going to be equal to the cosine of t. And if you think about it, the tangent, we said, in this case, the tangent of t is supposed to be y over x. Well, here's something. Then the tangent of t is equal to sine over cosine. So the aha moment is, well, if it's every point along this unit circle is x comma y, well, then it actually has coordinates cosine t comma sine t. Think about that for a minute. That is insane. So what I want to do is I want to talk a little bit more about the unit circle, but we're going to do that probably in class. So one thing that is important is to think of what's called reference angles, and they are positive acute angles formed from the terminal side of theta and the x-axis. Basically what it is they are what's the small, you got key reference angles. You got the 30, you got the 60, you got the 45. Those are your key reference angles, and that's what we want to use. All right, so think about this, and I'll show you what I mean. Check it out. What's a reference angle to negative 480 degrees? Well, if you look at where negative 480 degrees is, it spins all that way around. So realistically, this guy takes on the same features as what angle? Well, what you can think of is, well, I spun around. If you go in the positive direction, I spun around, looks like a little bit over 540, right? Because, I mean, if I go the other way. So then this is like 540 degrees minus 480 degrees. So it takes on the value of whatever the things go on with 60 degrees. 290. Well, 290 degrees is this way right here, right? So that's this angle. So this angle, I mean, you could think of it like how much left over from 290 is left of 360. So what you could do is you could say, okay, well, it's 360 minus 290. Why did I take that away? Because I want a positive angle, and it's 70 degrees. All right. Yeah. And then so then if you look at the next example, now we're talking about radians, 23 pi over 14. Well, 23 pi over 14 is in the fourth quadrant. It's over here. So what I'm going to do, if it's 23 pi over 14, it looks like it's almost it's not it's 23 pi over 14 is, well, if you think about it, 2 pi is 28 pi over 14. So let's see. Yeah, but yeah, 2 pi would be 28 pi over 14. So this guy right here is in the fourth quadrant. So what I'm going to do is I'm going to go ahead and I'm going to take, it's almost to 3 pi. So 3 pi minus 23 pi over 14. Well, 3 pi is 3 times 14 is 42. So 42 over 42 pi over 14 minus 23 pi over 14. Well, that's going to get you 19 pi over 14. That's your reference angle, is 19 pi over 14. How about negative 7 pi over 3? Am I going to add 2 pi? Am I going to subtract 2 pi? What am I going to do? Well, what I'm going to do is I'm actually going to I'm going to take negative 7 pi over 3, and I'm going to add 6 pi over 3 to it, and it gets me negative pi over 3. That's my reference angle, if that makes sense. How about the sine of 120 degrees? Well, the sine of 120 degrees, you got to think of where you're at. The sine of 120 degrees is going to be well, what's the reference angle? Well, that's going to be, it's basically kind of like the sine of 60 degrees. And then what about the tangent of negative 405? Well, that's way bigger than 360. So I'm going to basically say that that's like taking the tangent of 45 degrees, if that makes sense. We'll talk deeper about what some of these mean and where you're at in class. I just wanted to kind of touch base on them a little bit, get you an idea of what we're talking about, and we're going to go a little more into detail with the unit circle in class. So just be mindful of this, and I look forward to seeing you in class tomorrow, and may the force be with you.